This is Lab 4 bar magnets. So our intro, our purpose is to look at a bar magnet, see how they work, then code it into GlowScript. For my preview, I got a magnetic moment of that guy right there. 3.28 amperes per m squared. And this is a picture of our code. So for my key physics principles, pretty much all we really needed for this lab was calculating what a magnetic field looked like, which is it just looks like an electric dipole. So I pulled these two equations, but the equation we really used when we're on axis is this guy, which is a lot more at estimating. This one's easier to do by hand, but this one's easier to do on a computer. Then for my system, we have the bar magnet. We're measuring its magnetic field. And for surroundings, we have Earth and the nearby electronics that we were using. For my initial conditions, we tried to align the phone slash magnetometer to Earth's magnetic north. So for our actual experiment, we set up and found where the magnetometer was and started sliding this uh, bar magnet until we read what we wanted it to be. So for this one, we looked at the magnitude of 20, then 70, then 120, and we wrote down about how far the bar magnet was to the phone, how close it was, and then it calculated the averages of all those numbers. Then we had to look at some math. If you rearrange the equations from earlier, you can get it to look like the natural log of the magnetic field versus the natural log of uh, the position to find that this guy is our thing. So we found that the y-intercept on natural log of b would be this guy, which is what we saw in our preview. So for coding, I just put this equation into code form, which is down here, and then we ran a whole bunch of observation points through it, and it all made sense. We had um, point here pointing this way, point here pointing this way, because if our magnet is like, let's say, this is south and this is north, then it'd obviously be pointing this way from both sides. And then when you're looking at it from a perpendicular point of view, this is the z-axis coming towards us. It'd be pointing the other way. Then we have our off 45 angle, which is pointing in some weird direction, which still makes sense for where it is and what it's doing. Um, so yeah, some sources of error. We're not perfect. Our Earth would still mess up our measurements, which would mess up our magnetic moment. And then there was also a whole bunch of electronics that also were producing a magnetic field, like our computers or iPads. And then there was like the metal underneath the table that was probably doing something as well. Then the other issue was that we were using our eyes to measure how far across the bar was on the meter stick. And, we're once again human. We can only see how close or how far it is based on assumptions. Or what if questions. What if you hadn't oriented our experiment to compensate for magnetic north? It's exactly like I just said. Um, our results would have been like shifted or blurred by however much we didn't account for the Earth's magnetic field. The results would have been similar, but all shifted by an amount. What if you were to stick two identical magnets together end to end and run the experiment again? Technically, our magnetic moment should double, so all of our arrows from earlier would also just become the same thing, but bigger. Or, I thought about it a little more, the length would also be taken into account of the magnetic field, so there might be some issue of not being quite double, but it would be bigger, pretty much. Thank you for watching my thing. Hope you have a good day. Bye bye.